11 responses, so that's good.
Whatever is going.
It's not too bad. Cool, right.
Clip it later or something.
Okay, so we're going to kick off again. So I didn't see much of Blair's talk because I was cutting pizzas. I hope you all enjoyed the pizzas. But the bits that I saw were great. I will watch the video again. So next up we've got Ian Thomas, who will be talking about algebraic programming safely with types. Yeah. Ian's fantastic. He will talk your ear off about anything. I've seen a version of this talk and it's really good. So yeah, thank you very much, Ian.
Thanks. Right, so as Luke says, this is something I'm keen on. And if anyone has chatted to me about JavaScript and types, it's normally with me saying how much I dislike TypeScript. So if you are coming to this with a view of, here I am talking about TypeScript, I'm going to blow your minds by not talking about TypeScript at all. So starting off, does JavaScript have types? Potentially obvious question. Some shakes, yes. Some no, yeah. To an extent, yeah. So when I asked this around work, a lot of people said no, which is quite interesting because JavaScript does have types. It's got 6: undefined, null, boolean, string, number, and object. So there we are. They're the mighty types of JavaScript. So moving on to the other part of the title, what is safety? This is probably a little bit more subjective, but for me, what this largely means is, am I going to see something go wrong when I didn't expect it to? So if I'm writing safe code, I'm not going to see errors, but if I'm not, I'm going to see loads of them. And so I thought, as a little bit of research, I'll go and find out what the most frequently reported errors are in JavaScript applications. Now this is client-side stuff and it's from Rollbar, but you can see there's a fair theme amongst them. Type error, type error, type error, some security stuff from third-party scripts, type error, type error. So it's all fairly much of muchness. Looking at the Skybet error stats, it's not much different. So from the start of September, I took a snapshot for a type error class, and we just had the lowly 1.07 million of them. We really are excellent engineers, I promise you. So it's quite a common thing, a type error. And so often when we talk about types, people talk about things like type safety. So again, looking more at a concrete example of what that is, computer scientists say that type safety is the extent to which a programming language discourages or prevents type errors. And often the behaviours that they're classified as type errors are from trying to use something that you think is one type and actually is something completely different. So going back to those errors, you can see lots of them are, I can't read a property from this thing, undefined isn't an object, null is not an object, undefined isn't a function, that's a fairly classic one. And you can see that these are generally like the massive majority of the errors that are getting reported in this top 10 list. I think if you added them all up together, it's overwhelming, it's up towards 90% of them. Another aspect of talking about types is people often talk about types being static or dynamic or strong versus weak. I personally don't like to use strong versus weak because I don't think it actually means anything. People have a very loose interpretation of what that means. Realistically, a type system can be described as static if it's the types are evaluated at compile time, or dynamic if they're evaluated at runtime. That sort of leads a clue as to why JavaScript isn't safe, because JavaScript is a dynamic language, so you don't catch a lot of these things at compile time, because they're generally, well, I guess up until a few years ago at least, there wasn't really much of a compile step. TypeScript obviously will help with this, but I believe there's a better way. Before we get to that, little game of spot the difference. So I've got const A is null, a.prop, and that's number 1. Const B equals undefined, b.prop. What happens at 1 and 2? So we'll start with number 1. What happens at 1? An exception? Yeah, 1 blows up, type error, can't read property prop of null. Number 2? Exception again? You think exception? No, number 2, it's JavaScript. It silently fails and returns undefined. lovely consistency that we're all used to. And it's especially interesting because apparently null's an object. Who knew? Right, so looking at some concrete things that might cause us to have some of these errors. Getting the first item from an array. In this instance, what should we return when we've got an array with items in it? Or what should we return when the array is empty? Or what should we return when we don't even have an array? We don't really know. It's difficult, isn't it? Because you've got to try and handle these different cases in different return types. The happy path's quite obvious, but what do we do about handling the failure? We'll come back to this. Some of these are the ones that I've seen in programs before. I think if anyone's worked with sort of jQuery type JavaScript in the past, returning false was quite a popular thing. Another example, accessing data nested in objects. Something that we do quite a lot as we work with JSON APIs more and more. If we have two objects, A and B, and we want to get the sum of the property C, which is nested deep in it, what do we put in that body of the function? A naive approach might be to do something like this, where we write a little add function, and we say, well, we know that we've got A, B, and C, so we can use reduce on that array, stick add in there, use 0 as the starting value, and Bob's your uncle. Works fine if you've got A, which has got the right value and the right elements in that value, but what happens for B? Well, that results in a type error and your program explodes at runtime. What sort of improvements can we make here, bearing in mind that we've got to handle this failure case? We might instinctively look to add a guard clause, so we don't just blindly assume it's an array. We'll stick something in that proves it. Obviously, I've done a bit of shorthand here. You'd probably have to check every single step of the way, and then we check that thing that we've got, that path value is actually an array, and then happy days we can run our reduce with our add function and 0. But we've still got this problem underneath of what do we actually return when it's not an array or it's empty or whatever. We don't know. How do we represent the failure branch in that function? Again, going back, there's some options here. One would be we return false. Another one would be we return null. We could throw an error, just a generic error with a message in there saying that we need an array that we can sum. Or we could throw a specific error that we've written. There's probably more options, but I think you'll get the point that I don't think these are the best way to do it, because they're all resulting in something that is unexpected from your function. If we're regularly accessing this sort of nested hierarchy, there must be a better way that we can do it. There must be a way we can formalize this approach and make it reusable. There has to be a better way. And anyone who knows me knows that I'm going to talk about functional programming, so no surprises that it's pure functions, consistent return types, and largely immutable data structures, which brings me nicely onto the topic of my safe JavaScript talk is ADTs, or algebraic data types. Now I'm going to use the library Crocs to sort of explain through some of these approaches. This is really good, not least because it's written by somebody called Ian, which is a fantastic endorsement in my mind. But it's excellent, it's really pragmatic. A lot of the functional programming stuff you'll see around the web can be a little bit academic and a little bit in its own environment, and it doesn't sort of step outside that to acknowledge that the rest of the JavaScript world exists too. So Crocs provides you with quite a good variety of algebraic data types that allows you to start to produce programs that are declaratively put together rather than imperative. So when we talk about declarative and imperative, it's more, if I'm declaratively programming, I'm just saying what I want to happen, rather than imperatively I'm having to step through and say step by step by step exactly what I want the computer to do to reach the end result. And in this case, for what a lot of the safety stuff, we can use a type called sum types. Now, sum types, I don't know if anyone's come across these before, but they're a way to express a disjunction or options in your programming. If you think about a typical JavaScript object, that would be considered a product type, because if you have 4 or 5 properties, the number of different values that object can represent is the product of all of the number of values that each of the properties can represent. So if I've got something that's got 2 properties and they're both numbers, it's the whole range of numbers times by the whole range of numbers. Whereas a sum type, if you think about a Boolean, that's a sum type. It's either going to be true or false. It's an addition, so you've only got 2 options in that case. Hopefully that will become clearer as I go through some of the following slides. First, a quick intro into the Haskell-like type signatures that I'm going to be dotting around various examples in this presentation. If I'm declaring a sum type or a user-defined type, it'll probably be something like this, where you say a bool is the type name, and on the right-hand side of the constructors you can have an alias, which is basically just remapping an existing type to a new name to give it a bit more semantic meaning. And then what I use a lot is these function signatures to explain kind of the name of the function add, and then what I'm expecting it to take in. So in Haskell and in these type signatures, the way that these work is this says this is a function add that requires an int and an int as arguments, and it will return an int. Okay, and the arrows imply that these are curried, so you can give this function one or more of the arguments at any one time, up until the number it needs to return the end value. So going back to the safety aspect, I'm going to introduce a type called maybe, and maybe allows us to model the absence of a value. So in this instance, we're saying data maybe A is either just an A or nothing. Now the A is significant because this is just saying it's generic, it could be anything. The just doesn't really care what's inside it, it just needs to know that it's going to hold something, a value that you can use. Whereas nothing, obviously there's nothing else that goes in it, it's just modelling the absence of a value. It's very good at capturing this disjunction where you're not sure what the error is, or you don't need to use the error, you just need to know that it isn't going to return something useful. So going back to my example, we can rewrite this so that the return type of sumC in the happy path case is a just of the result of summing up all those elements in the array. And if there isn't anything there, or we can't do it, we just return a nothing. We've got a consistent return type there, we've got a maybe, so we know that we can always depend on this thing having certain properties, but because we've got the two branches that it could represent of a just or a nothing, we can then work further with that data to produce a chain of computation that will allow us to build up our application in a safe manner. There is something about this that's not quite right. I don't really like this. This is better because we're getting a consistent return type, but this feels like it's very much like do this, do this, do this. There must be a way that we can abstract this out and make it more reusable. Going back to crocs, there is a couple of really useful helper functions that are under the maybe type, which are prop and prop path, which basically encode this behaviour for free. You can say, given prop A and this data, return me the thing if it's there or nothing if it isn't. And if I want to get something nested, we can encode that hierarchy by providing an array of A, B and C and the data, and it will look in the object at that path and return the thing that's there if we want it as a just, or if it's not there we just return nothing. Again, these are curried, which is really useful for thinking about it later, so we don't have to provide the data up front. You might be thinking this is all great, but how do we actually use this data? If I've got a just, I actually just want 6. This is where we start to get into the fun bit. Maybe as a functor. Now, most people will have come across something that is a functor in terms of working with an array, but it is more general than that. It's part of category theory, and it's basically something that provides a map method, which allows us to work with the value that's inside it. So all of these types can be thought of as containers, and if we need to work with the value that it contains, we can use map to access it. Again, nice Haskell-like type signature, which basically just says map is a function that requires f to be a functor, so it has a map, given a functor containing an a, and a function that takes that a and turns it into a b, I will actually get another functor on the other side that contains that b. Again, you might be thinking, well, what happens with this nothing? If I'm mapping over it, then what am I going to do there? Well, basically nothing. It short circuits. It doesn't need to do anything. So if you've got a just, the map function can be written something like this, where you provide it with a function and it will run it on the value contained within that just. But if you've got a nothing, just return a nothing. You don't need to do anything. You're basically just able to go through your computation and say, well, there's nothing here to work with, so don't work with it. Using the helpers from crocs, this can again be rewritten so that instead of having this imperative style, we can say, well, we've got a chain of computation here which is composed of a couple of different library functions. So given this data, pass it to the prop path function, then map over it, which if I've got of some values will be passed back, it'll give me the array, and I can do my reduction here. But if it's a nothing, it's just going to ignore this. It's going to basically do nothing at all and return nothing at the other side. So again, I've got my consistent return types, and I've got a much simpler, in my mind, you be the judges, I guess, way of explaining what this program is going to do. I've just built it from parts that are already well-defined, well-tested. I mentioned currying before. Now this is really important, so this allows us to go beyond what we've got there, because you might have noticed that we've declared data twice. You don't often need to do that in this sort of style of programming. And that's where the currying and the composition come into form, this style which is called point free. Now a point is generally considered to be the declaration of a parameter in a function, and point free programming is a way of declaring what your program's going to do without having to create these parameters. It will become clearer as I go through. So if we look at the type signature for prop path, you can see again it's asking for this foldable. Now all this foldable means is this is something like an array that we can iterate over to produce or to look at values and do stuff with. So with a foldable f that's going to be taking either strings or integers, we can pass it an object a, and it will either find it and bring it back in a just, or it will bring back nothing, so it brings back a maybe a b. In that you can see that here we know that f has to be an ADT. The arrow indicates that it's curried, which is very important, and then this value is only returned if all of those values are returned. So is everyone clear what currying means? I realise I've just rattled through that but not really explained it particularly well. If you think of using bind or something on a function where you can pass some of the arguments and it will return you a new function that runs later, currying is the same sort of idea where you can pass in one or more of the arguments required for a function, and then it will return you a new function until all of the arguments are passed in, and then it can compute the value that's on the other side. Digging into the library a bit more, I don't expect everyone to pick this up, it's a bit of a wall of text, but these are some of the functions that are provided, and these are really important because they allow us to start to build this point-free style of program. Map and reduce are basically just ways of saying, give me something that's going to have a map or a reduce method on it, and I'll call it with the function you give me. Compose and pipe are kind of the same thing, just one composes functions from left to right and one goes from right to left. But it's essentially a way of saying, given these functions, I will take the output from the first one and provide it as the input to the next one, the output from that one to the next one, depending on how many you give it. And then prop path is the old friend that is going to allow us to pick stuff off of an object to then use later. Going back to this example again, we can start to build up little functions that are going to help us to produce our overall application by saying, well, we know we're going to want something to get C, but we don't need to provide it with the data just yet. So we can create a new function that's going to wait for an object and return maybe a B. Then underneath that, we can sort of say, well, our summing is going to require an array of numbers. We're going to use our add function, passing the empty value of 0, and then that's going to be a function waiting for an array to be passed in. And then we can use this pipe function to create our overall app, which is going to say, run this first, then with the output, we're going to map this sum function over the top of it. So it's exactly the same thing, it's equivalent as the one before, and hopefully, if this works, you can see it working. So again, I've just kind of brought in the library elements from Crocs. These are the various test cases I've got. So you can see if you've got the right thing, you get just of 6. If you don't have anything, you get nothing. Even though we're saying we're going to do this map, it's just not going to perform any kind of calculation at all. And then this very last one, slightly different type. Again, that's nothing. So there's apps that doesn't even go far enough to get you to a C in that. So you can see it's a nice way, once you get used to the type signatures and once you get used to the ideas behind it, you can start to build up your computation from very reusable generic building blocks. I haven't really written any code other than this add function here. And this is all well-tested, battle-hardened stuff that people can use day in, day out without too much trouble. Now, can I do the same for my presentation? Yes. So our final implementation can look something like this. We can pull these out to be helper functions if we need them, or we can just say this is my composed function that's going to be getting the property off the object, and then oh, hold on, I've gone too far. don't put Code Sandbox into a presentation. Where are we going? No. It's not liking that, sorry. I've missed out a whole chunk here where I introduced monoids, which is very exciting. Oh, we might have to give this a kick, sorry.
Sorry, is it a PowerPoint? Because probably you can't exit it then.
It's not, it's slides.com. I thought I'd go rogue and try and do something with an internet thing. It's completely failed. Right, let's see. So we could use a monoid. I think this is the point I was trying to get to, is that when you've got this in here, it's the wrong example, but you've built this thing up where you're piping from one to another, and you can provide your final summing code in the middle. But yeah, we want to be looking at the reduction. It's this bit here that I was interested in. So obviously I'd written this add function. It's really simple, so in this case it's very trivial. But sometimes you're going to want to do more complicated stuff, right? So with this we can say, well, what's it doing? This reduce thing is going to take two values and sort of smush them together. You could probably think of that as being concatenation. And the bit on the right of it is just the empty value, it's what to start with. Or you could probably think of that as identity. And in the wonderful world of FP and category theory, you could probably say that this would actually form a monoid, which is what we're going to do. So any ADT that provides both an empty and a concat function can be used as a monoid. It's a generic term that can be used to talk about these types that provide certain behaviours, and it's mathematical based, so you can kind of rely on it holding true for anything that would be described as a monoid. Crocs hopefully also provides you with a lot of them that you can get going with. So obviously one of the first ones I would look to use here is sum. So instead of saying I'm going to reduce with this add function and 0, sum is a monoid or a type that encodes this behaviour of add and this identity of 0 into a type that I can then pass to an mReduce function, which will then do exactly the same thing. These are both the same thing. It's just that this is generic code that I'm just plumbing together to say what I want to happen, whereas I'm actually having to write this bit up here. And obviously a trivially small function like add, it's straightforward, you're happy to do that, but as it gets a bit more complicated, it's obviously better to rely on something that's a bit more well-defined, has more concrete mathematical basis that's behind it. This is where it gets a little bit more kind of into the specifics of the library. Crocs offers you 4 ways of working with monoids. mReduce, mconcat, mReduce map and mconcat map. The thing you need to know is that when it says reduce, you get the value out the other side, and when it says concat, you get a container with the value inside it. The map bit means that you can run a function on the value before the monoid work happens. Type signatures. These slides are online. That's one of the benefits of slides.com, I guess. So you can have a look at this later. But yeah, essentially, the main difference is that the thing you get out of concat is inside a monoid, whereas the thing from reduce isn't. It's just the actual value to use, which is why I chose to use it in that example. If we jump back to getting the first item from an array, this now becomes quite straightforward. We can say that if we've got an array and the length is greater than 0, get us just of the first thing, or give me nothing. And I think there's a deliberate typo on that one where I've put the semicolon in the wrong place. No prettier in slides.com. Right. This is the other way of writing this, just if you're not very comfortable with the kind of really shorthand fat arrow style syntax. I did this as a workshop at work a few weeks ago, and people weren't that familiar with this kind of style of writing code, and it's just something I've done for a while now, and I appreciate not everyone does it, but they're exactly the same thing. what if you need to represent more than nothing? So one of the things that you would see is that sometimes there's an error that you actually need to understand what's in it. And thankfully maybe it's just the start of the adventure with these ADTs. There are other types that you can use that are provided by libraries such as Crocs, like eithers, which can represent an if statement, so it's a left or a right. You could have a result which encodes more of a kind of semantics around something failing or being successful. You can make them asynchronous so that you get something that looks a bit like a promise where it might be rejected or resolved. Or you could take that even further by creating your own sum type, like a remote data type thing, where you can start to encode things like, have I asked for this data? Is it loading? Has something failed or has something succeeded? And if anyone's ever worked in a front-end application where you have to try and model the state of something that's going to be not started, loading, failed, or successful, you end up with loads of booleans that offer you more options for state than you actually need. So if something's loading and failed, what is it? Who knows? So this is a really nice way of encoding that state. And it's probably a separate talk, but it's really interesting to think about the difference between state and data. I'll leave that with you. And then there are even more generic versions of this. So you can have a pair where you might have two different types that's contained in left and right, and then that can take on the properties of any ADTs that you put into them. So if a pair had, I don't know, say a list in the left and list in the right, then you can have things like concatenation, and you can have mapping and reducing and all that sort of stuff that you want on that type as well. So it's all great, but why the crazy names? Generally, it's all because people are trying to find the patterns that exist in mathematics and apply them to the patterns that exist in programming. It's not someone just sitting in a room and trying to say, well, I've made this thing and I'm going to come up with a crazy name. These are actually common rules that can exist outside of programming, and they're just going to apply them to the structures that we are creating. But one interesting thing is, if you ever look at this online, it generally comes under the topic of Fantasyland, and people often wonder why Fantasyland. And I think it comes back to a discussion when people were trying to formalise the A+ promises spec, and someone said, why can't we just incorporate monads and category theory? And this was the rather terse reply that they got to say that this isn't a typed language Fantasyland, on the back of which they went off and wrote the Fantasyland spec to actually make all these things happen. It's quite an interesting read if you have 10 minutes. If you're interested in this stuff, and I appreciate I've blasted through it, there's an awful lot in there, especially the type signature stuff. There is loads of other stuff you can do. I've got a little workshop on GitHub that offers you some exercises to then start to put some of these ideas into practice. There's the Mostly Adequate Guide, which most people will talk about, which is a thing from a guy called Brian Lonsdorf. It's great, but it's a Git book. There's an Egghead.io course, which is the composable functional JavaScript, which is the same person. It's actually an animated hedgehog. Yeah, I think you can't go wrong. Although, is it a hedgehog? I think there's a debate about that. This Fantasy element specification walks you through from the very basics of the Fantasyland spec. So it takes you right from defining sum types up the way through functors and monoids and semigroups and all that sort of stuff. And it's really well written. It's by a guy called Tom Harding, who spends an awful lot of time helping people on Slack and other areas to really get to grips with this. I'll be honest, I've been trying to get to grips with this for a long time, and the thing that actually helped me the most was working with Elm. So if you do have a chance, pick it up and have a look at it. It doesn't go the full way with some of the monad style stuff that you get in Fantasyland and other more pure functional languages like Haskell or PureScript, but it is a really good starter, and a lot of the ideas that it brings are enough to make your programs better. I find it was a really good way to start to understand better how to work with things like Redux and more functional JavaScript. And then EvilSoft is the chap Ian that wrote Crocs. He does some live coding sessions on YouTube, which are definitely worth a watch. They're a bit long, sometimes you need to jump ahead a bit, but they are very useful. And then if you're really, really stuck for something to do, you can go and look up ADTs on Wikipedia. So that's it. I'm sorry about the code sandbox issue, but if you have any questions, please come and grab me. I'm more than happy, like Luke says, to chat your ears off about this stuff forever and a day. So thank you.